Right. Yeah, so quick thing, I'm just going to be here to talk a little bit about some interop within .NET and whatnot. From the slides, you'll be able to see you've got C#, Visual Basic, F#, and the .NET bot. So to start off, as is mandatory with every talk, here is a little bit about who I am. So my name's Adam Parker. I'm a software developer. I've been doing .NET for, I'd probably say, most of my career. Obviously, I've dabbled in other languages and stuff like that for different bits of work, but mostly .NET. You'll probably see me online a lot as a little gopher icon thing here. But my notable achievements, unlike a previous speaker who's a Microsoft MVP, I got creating this talk. I've got learning PowerPoint animations for this, and also I've got a room full of people who are willing to listen to me talking about .NET Interop, which I think is quite an achievement. So what's actually going to be covered here? So this is sort of just a quick rundown. So first is a quick look at the word interoperability. I'm going to go through like official definitions and what I'm actually going to talk about, because I blurred a line a little bit against the official definition. Differences in object-oriented languages. So we've got two different object-oriented languages. What happens if you try and use them together? Does anything go wrong, and so forth? And then the final part will be the object-oriented programming and the functional programming languages. For those who don't know what functional programming is, it's a different paradigm that is less popular than object-oriented. But we do have a first-class language in the .NET ecosystem that uses the functional paradigm. So we've got when things work, when things don't, and also there's somewhere it's kind of half and half about whether it works or not. So the first thing is, what is interop? And Microsoft has this fantastic definition that is really in depth and actually covers the whole landscape of what interoperability in .NET is. And it's all about being able to talk to all these other languages, both inside and outside of the CLR, inside managed code or in unmanaged languages such as C++ and so on. Doing all of that for a talk is a little bit too much to cover. So for the purposes of this talk, we're going to go with my definition, which is using libraries from other languages in your project. And we're going to stick within those languages that are fully supported within .NET itself. So the three languages that are actually supported are C#, as I'm going to assume most people here have probably worked with at some point in their career. Visual Basic, which is probably the next one that most people here may have looked at some point in their career. And also F#, which is the one that I imagine that nobody has ever heard of because it seems to be Microsoft's forgotten language of .NET. So let's start off with the easy one. This is Visual Basic and C#. As you can see, they're both object-oriented programming languages, and they're sort of the exact same sort of class put in both languages, and you'll see there's sort of similar sort of things going on. So you've got the class keyword there, you've got these functions that are inside of the class, you have this concept of like private variables and all that kind of stuff. So these two languages look very, very, very similar to each other, and that's because they both work on the same paradigm. So as you can probably expect, because everything compiles down into the .NET Intermediate language, and all of these concepts of object-oriented languages are first-class citizens in the intermediate language, as you can imagine, these will just work absolutely fine together with no issues whatsoever. So if I take my mouse cursor here, as you can see, this is a Visual Basic program, and at the top here, as you can see, I'm instantiating that instance of the new C# class, calling all the methods on it, no issue whatsoever. So you've got no problems using these libraries in console applications and so on. And if you need further proof of this, hidden inside of this little code snippet here, you'll notice that I'm actually importing newtonsoft.json, which is the one and only JSON library for .NET until Microsoft decided to kill it with their own system.json. But yeah, so obviously that's a library that's been used by millions of .NET developers. It's used in C# applications all over. It was used in ASP.NET applications at default deserialization. And there it is being used in Visual Basic without anybody even noticing or even thinking about it. There is nothing wrong with that whatsoever. It looks exactly like you would write it in Visual Basic. So that's the easy part. That is when you have two languages of the same paradigm that are working together, and it just goes absolutely flawlessly. So moving on. There you go. So next we have F#. And as I mentioned before, F# is a functional programming based language, which might sound really weird, and it might sound really odd, and I'm not going to try and teach functional programming in this talk because that is a whole topic. If you're curious, go and have a look. It has some really interesting properties and it has some really interesting things you can do with it, but that's not the purpose here. But there's a few bullet points on there, and some of those will sound completely and utterly alien to you, and that's absolutely fine. I'm going to do my best to give the brief explanations that I do have of them in here, but these are some of the things that you'll find in F# that just don't seem to actually have any sort of counterpart within the C# or Visual Basic languages. Okay, so first things first, we'll start off where things are going to go well, where things are going to just work like you wouldn't even know that you're using anything F# in your C# project. So the first one is namespaces and modules. Namespaces in F# work exactly like you'd expect them inside of C#. And so you just import it with the standard using statement and everything works smoothly. Modules are the way that F# actually tries to break up its code. And so, while you can put namespaces in to try and make this sort of, this crisscross easier, what you'll find is that the modules part of it, just go to the next one, basically just ends up exposing itself as a static class to C# and Visual Basic, right? So you don't really have too much to worry about, but when you're organising your code like this, you can still organise it exactly as you would normally in an F# code base, but you might want to put namespaces in there just to make that interop a bit easier to use and to make it easier to work with. But as you can see here, so I've got this functional paradigms things, I have this postcode type, and bring it in, I can just say, hey, give me a new postcode and create it, and it's just, that looks like normal standard C# code. So that's no issues whatsoever. The next thing is values and records. So values, obviously, that's just a number. That could be anything. That could be a string. That could be, an integer. It could be an entire type, whatever you want. And as you can see there, again, it's just a static class. So all it does is it takes that value and whacks it on there as a public static member. So you don't need to instantiate the class. You don't need to do anything. Everything that you would get with static is kind of what you would expect to get from this kind of thing. And in the next one, with records, so records in F#, and it may seem weird to talk about records in F# as being something separate, but back before .NET, I think it was .NET 6, you might remember that C# did not have this thing called records, and you only had classes and so on. So records, as you may now know from C#, are these immutable data structures that have structural comparison. And they've been in F# since the start. So there's an instance of one being used, and basically what this ends up doing is it generates, well, effectively what you would have had to handwrite before to get the equivalent of a record. You get a class. In this case, it ends up being sealed because, in F# you wouldn't have any way of subclassing this kind of thing. And so you end up with a sealed class that has a single constructor, and all those things get turned into public properties, right? And, they're get only, and it's great. And you end up using this class as if it was almost just like a record in C#. You do end up losing that nice syntactic sugar for updating records because obviously this was built before records existed, and also if you need the further evidence that F# is Microsoft's forgotten child, this still has not been updated. So when you compile an F# record in modern .NET, it does not go to a C# record, it still goes to a C# class that needs to be, have all these things generated and whatnot, and therefore you lose that sort of syntactical sugar that you might be able to use otherwise. But nonetheless, it was there, it worked. This has worked all the way since the first time that I gave this talk, back when it was .NET Core 3, and it's still there. So yeah, sequences are effectively lazy loaded sort of, lists or however you want to call it and whatnot. In there you can see I've got a thing that says, hey, for all of the numbers from 1 to 10, just do the square of it and return it. And that's going to generate that sequence, and it's lazy, it's all good. You'll note in the C# code, it exposes IEnumerable, and obviously that kind of makes sense when you really think about it. When we use IEnumerables, we don't really think about actually bothering to enumerate them until we go .toList or whatever, or things like that. And so this idea of a lazy sequence is obviously extremely portable over to C# as well. So yeah. Functions. This is one of those things that might seem a bit odd, because functional programming, spoiler alert, it's a very, very big thing in F#. You'll use them an awful, awful lot, right? So in here, at this top one here, let a function that takes in a string and it's just going to return the length. That's fine. And as you can see in the second little snippet there, it's just a static function. The third one even shows you the exact type signature that you get from writing this module in F# and trying to use it in C#. Absolutely fine, and there is the caveat here of as long as you don't take a function in as a parameter or return a function as your return type. An example of sometime that you might find this useful is if anybody thinks of like link statements, anytime that you would use a select or anything like that and you pass the lambda in, that is taking a function as a parameter, and we'll get to that later on, because that one is, well, interesting to say the least. But yeah. Discriminated unions. Brief introduction to discriminated unions. They're a type that has a certain set of subtypes, and the compiler will check, in F# at least, to make sure that you are guaranteed to be handling every subtype of that when you're using that base type. That's the brief introduction. If that doesn't make any sense, then I apologise, but it's the best description I can give. So we can just assign some numbers to them in F#, and this comes through as an enum, and it's great. Like literally, you won't find any issues here. Not a problem at all. You see, even the enum has actually got its 1, 2, 3 numbers on there, and that's fine. Use it as you expect, When you put types onto these discriminated unions, so this is one of those things where, let's say you can have like this base type, and there's all these subtypes which can have different structures and what have you. So you've got an integer on the error, a thing like an error return code, a warning. You might have, oh, this is the warning number and this is the warning message, or info, this is just the informational message, for example. And this gets quite interesting because it generates something that's actually used in other languages, which is a tagged union. And I apologise, I realise it's probably very, very small on there, unfortunately. But what you get is you get an abstract class of the first type, so in this case the other log levels, and then inside that nested class you actually get a bunch of subclasses inside of it, one for each one. So you'll get the warning, I don't know if I can, oh I can, that's handy. There we go. So you'll get the abstract class here, and inside there, as you can see, we've got this static class for tags. So this is where it comes into what they call a tagged union. So you have a list of tags that determines which type it's going to be. And then you can also see here, we have a public class of warning, a public class of error, and info, and they all have a subclass of the other log levels. And there you can see you get this item which determines the type, so integer string for our warning, int for our error, and string for our info class. And then of course you have all these overrides as well, because everything in F# is structurally comparable, so all of those overrides are needed to make sure it performs the same way in C# as it does F#. So yeah, whoop. I appear to have gone too far in. And where was I? There we go. And final one is unit. F# does not have the concept of null. It doesn't exist. You have unit. And unit is effectively a really nice way of saying, hey, this doesn't return something, or I don't need any parameters, right? But as you might expect, the easy way to translate that over into C# land is, if you return the unit, you will get a void return, and if you take a unit, it's going to be null. You can pass null. That's effectively what that means. So that's that. Now, are there any questions about the stuff that actually works well before I continue? No? Cool. So we'll move on to things that are halfway there. Lists. So lists in F# actually end up being shown as a completely separate type. There is an fsharp.core package that you can use to make sure that you get all of these types and that you can use them, but obviously it would seem a bit weird to be in your C# code base and importing, hey, let me just import fsharp.core, especially as somebody who might not have any F# code in their project at all. You know, you might just be using a library that's been built in F# for whatever reason. But one of the positive things about this is that it does also implement that iRead-only collection interface. So you are more than welcome to just cast it as that, and it will work absolutely fine without any issues, and it just carries on as normal. And obviously that type is in the C# standard library, so you're more than welcome to use it. But yeah, so you actually have a type that is called fsharp_list. Just trying to avoid it if you do decide to do this kind of stuff. Discriminated unions, which I know seems really odd because I said they work really well before, but that's only if you actually put that number designation on the discrimination unions. So if we go back a few slides, you'll notice in the log levels I have 1, 2, 3 on there. If you leave those off, as you can see in the animal example here, it's either a dog, a cat or a parrot, well, it doesn't really actually work that well because you don't actually get like a proper type. What you get is you effectively get a single class that just has a tag. And I mean, you know, the static methods on here are purely to get this, you know, it effectively creates a singleton instance of that type that is of animal. And so you have this tag, and so what you end up with is you end up with this really quite ugly sort of syntax here where you need to switch on the tag or do an if statement or an if check on the tag to find out what it is that you're actually working with to be able to determine how you want to use the particular part of it. So yeah, in this case, you know, I set the animal to a cat, switch on the tag, it's going to end up printing out a cat. But obviously it's not really nice syntax there, and you would also have to make sure that you're checking every single one of those, and if you don't have that default case statement, well, eventually you're going to get into a case where you don't know what you've actually hit because you missed the case because somebody went and added a new type to this discriminated union. So obviously that's to be avoided as much as possible. So it works and it's usable, it's just not very nice. Options. So remember before I said about the fact that F# doesn't have this idea of null. They represent it within the type system itself through this thing called an option. So an option is either, hey, I'm something and I have a value, or I'm nothing and I don't have a value, right? And that's how F# makes sure that you're handling all these things where things can be missing correctly. And in this top snippet here, I'm just saying, hey, try and parse this value. If it's successful, we're going to return that some value with the result inside it. Otherwise, I'm just going to return none, right? That's great if it works. So in the second snippet here, I've got, hey, can you parse me the number 42? Yep, of course I can. I can get the value out and it's fine. And as you can see in the bottom one, the first val is 42. But if you pass it something that it can't do, well, go back to the first code snippet, it returns a none, and hey, hang on, our nulls came back. Null has just came out of nowhere because none, well, it just gets compiled to null because there's no other way for the CLR to know what's actually going on under the hood. So in this example, you don't actually get the nullable type back. You will just get the type back because the compiler was written before nullable types and just hasn't really been updated properly. So you just get that value back that just says, hey, I'm an integer, whether you know, I'm always going to be an integer and things are great. When under the hood, it's actually not really what's going to happen. So in this second example here, I try and access the value and that application will blow up and you'll get no compile time, you'll just get a, hey, you know, null reference exception, which is everybody's favorite, and I'm sure everybody in this room knows how great it is to get a null value exception and have no idea what's going on. So yeah, so there's that. Any questions on those before I continue? Once, twice, all in fair one? No? Great. So finally, things that should work, or things that you would expect to work that don't. Functions. Remember before I said that there was that whole caveat of, hey, if I take in a function or I'm going to return a function, then please don't do it, right? And there's a reason for that, and it seems really, really odd. So here's an F# function, and to give a quick overview of it, it's a function called doAstring function. I'm very creative with names, I know. It takes the string function and it's just going to perform that function on the string something, whatever it may be, right? Alright, so I'm going to call it from C# and I'm going to do this. And this probably looks very, very familiar to a lot of people. You know, alright, I'm going to do a string function. It's a function that returns an integer, and I'm just going to pass this lambda that says, hey, take in the string, find the length of the string, and just return it. That seems normal. That is what you should expect to be able to do. That is what you have to do, because F# functions are not the same as C# function types. And so you end up with this lovely syntax where you have to create an F# function of those types and then ask it to convert the C# function from its given type into the F# function type. And that seems really alien to me. I wish I had an explanation for anybody in this room as to why this is the case and why it hasn't been updated to match the functions in C# to make it interoperate better. There's probably a reason, I just don't know it, but that is one awful, awful bit of syntax to get something that should be relatively simple to work as you would expect in C#. So I've gone through all these cases, it's all well and good, it's all great to go, hey look, yeah, you know, all these languages can interoperate together, it's great, you know, some things are going to go well, some things are going to go awful, but, you know, it's one of those things of like, well, what's the point? Nobody is going to sit there and be like, hey, you know, I'm just going to throw a bit of VB and F# and C# and then expect some developer to come along and just be like, let's have at it and do all that and whatnot. Everyone just goes and writes everything in C# because it's what we all know, it's what we're all used to, and it's what we've all done. But there's an interesting concept to sort of take away from this idea. You know, it's firstly, there's the idea of using libraries. What if you want to use one of these libraries in one of these other languages? As you saw, you know, it might be I've stumbled into the one company in the world that develops an F#, but I really need to use Newtonsoft JSON, you know, because I really need a JSON serializer, and therefore it's there and it can be used, and that's great. You know, that's really, really helpful and beneficial for the ecosystem, and it also allows for things like, you know, we have other languages that are maybe not Microsoft supported, things like I and Python and stuff, where they were going to be done, and it allows for that broader ecosystem to exist, right? But the other idea is this idea of functional core and an imperative shell. In functional programming, the idea is that you're supposed to make unrepresentable states impossible to represent, right? You use the type system, and the type system will guarantee you that you do not have an unrepresentable state. And so using that idea, that actually comes really, really nicely into this idea of, like, you know, domain modeling, for example. You might have a very, very concrete domain that you know, like I work in banking, so, you know, I might have a savings account, and I have, oh, well, that account is in the, you know, it's been applied for state, or it's in the open state, or it's frozen, or something like this, and you can build all of that into the type system. And you can get this really robust way of having your code be handled and guaranteed that you're never going to get a bad state, right? The problem with functional programming is it does not like things changing. It does not like databases, it does not like HTTP, and those things are just alien because everything is immutable in functional programming. So this idea here of trying to create this core, all of your business logic, all of your, you know, your core domain logic that you need to guarantee is absolutely certain and secure and is correct, you can build all of that in something like F#. And then in that outer layer, you can just create ASP.NET, happily handle things in controllers, take things in, and then pass that off to the F# code, and it can then go and do all of the validation and all the type checking and do all of that stuff that you need as a guarantee. So that's one of those options there. If you want some more resources for this, there's a couple on there. The top one is my blog where I've got a few different blog posts up there about this. And also one that I realised I've missed off here is there's actually a talk. If you go to YouTube and just Google and just search on YouTube, functional core imperative shell, there's actually a talk by a guy called Scott Voloshin about, I think it was about a month ago, where he goes really more into depth about why that concept can be useful. But yeah, all of this is also available on GitHub. So there's a project that has all of these. You know, you have a C#, F#, and Visual Basic project and console application. So you're welcome to go and pull that down and have a look. You can see my blog handle there is Grabberbyte. That my GitHub username is exactly the same, and you'll find it under the .NET Interop repository. If anybody wants to just pull it down and have a play around and just see how it works, and feel free to break it. You know, that's half the fun of this, isn't it? Learning what breaks and what doesn't. So, yeah. That's the end of that. So I guess, is there any questions about this at all? Yep.
So I'll apologise if this is a stupid question, because it might be. Do you find if you're a library developer with F#, you might end up writing like a facade pattern, because you know you want to make it a bit nicer for different applications, do you?
Yeah, that's entirely possible, yeah, and you know, there are plenty of libraries out there. You know, I've seen multiple approaches for this. I've seen some F# libraries that create, you know, as you say, that sort of F# facade to allow it to be in and whatnot. I've also seen some, you know, some developers who actually do both and will actually create the C# library that sort of does that facading for them, because obviously then they're in the language and they understand how that's going to be consumed and stuff like that. So it is one of those things where it's like, yes, there is extra work to be done from it, but the benefit that you could get from it could be, yeah, exactly. So yeah, hope that answers that. Anything else? No? Coolio?